In this tutorial, we're going to expand our game to actually look at the enemies and their position, and when they move off of the screen to the left, what we're going to do is actually take them out of that list data structure that we have here. So we have this enemies list that holds all of our enemies that are on the screen and off the screen, and what we need to do is examine where the enemies are positioned, and if they have left the screen, we don't want to see them in that data structure anymore. We'd like to actually remove them from the data structure and keep our memory clean. Now, the first thing we need to do is actually display how many enemies are in this collection. And so we're going to modify our HUD to actually perform that. So what we're going to do is open up the HUD class, and then I'm going to add a label to tell me how many enemies are on the screen. So let's create a private label. I'll call it enemies. Now this is different than the list collection. This is a label within the HUD, but it'll have the same name. You can call this whatever you'd like here. And then here in my constructor of my HUD, what I need to do is set the enemies to be a new label. I'm going to position this in the X to be on the left-hand side, so almost all the way to the left. And the Y, I'm going to position it at 500, so it's almost at the bottom. So this will appear in the lower left. I'm going to set the enemy's width to be 300, so it's wide enough to display this text that I'm going to show. And I'm going to set the enemy's text to be equal to enemy count is equal to 0, right? Because initially there are no enemies. And then I'm going to add into my scene's root widget, like I've done before. I'm going to add child last, and I'm going to add the enemies. Okay, so this is going to create a new label and position it accordingly, and then it's going to add it into my scene. Now the next thing I'm going to do is here I need to create a new function so that I can tell the main game can tell the HUD to update this enemies count. So what I'd like to do is be able to pass in some string, just like we were doing with the update FPS, and I'd like to update the enemy count here. So it's going to be a public void function because I'm not returning anything, and I'm going to call it update enemy count. And you pass a string in to me, and I'm going to update the enemies text to be equal to let's actually not pass in a string. Let's actually tell it how many enemies are in the enemies collection there. So let's pass in an integer count, and then what it's going to do is it's going to take this in and display it. So the count is going to represent how many enemies are in my collection there. So let's say enemy count is equal to, and I'm going to do a string append here, and then whatever that number is that's coming in. Okay. So I've got this new function, update enemy count. You give me a number, and I'm going to update the label in the HUD to represent how many enemies are in that collection. So if we run this right now, we have the capability of showing the enemies, but it's never going to change. So if we run this here, you'll see that the enemy count is 0, but then in fact that's not correct. What we need to do is actually call update enemy count and pass it the number of enemies in the collection. So we can do that in our update function. Here, let's, before we do the HUD update, the display there, we can say HUD.update enemy count, and it's expecting an integer. It's expecting how many enemies are actually in that collection. So let's say enemies.count, and enemies is my list, and then the count property of the list tells me how many things are in that list. So I'll tell the HUD to run the update enemy count function, and I'm going to pass to it this number of elements or enemies inside of that list. So now if we run this, what we'll get is the number of enemies goes up. Every time I add a new enemy into that list, it is going to increase, and you'll notice that the enemy count keeps going up. Every 2 seconds a new enemy is being added to that list, and this shows the problem that we have, because even though the enemies are flying off to the left of the screen and we don't really need them in that list anymore, they're never going to show up again. They're not being removed from that collection, and that's a problem. Now in a real game that was professionally developed, you would want to do some intelligent memory management, and you might have an enemy pool, and you would be allocating from that pool of enemy or that resources. You would already go ahead and create a set of enemies and then just show them on the screen and recycle them essentially. To keep things simple, we're not going to do that. We're going to take a simpler approach, and in our handle enemies, what we're going to do is after they have been moved, I'm going to see where they are, and then I'm just going to take them out of the list. And by taking them out of the list, nobody is referring to that enemy that's been removed from this collection. It's still in memory, but nobody is referring to it or nobody's pointing to it. And so C++ has a garbage collector that's going to come along, and since nobody is referring to that space in memory, it's going to clean it up and delete it automatically. Now, we will get a performance hit from this, so in a professional game, you would not really want a garbage collector running around and doing this memory management for you. You'd want to do this and manage it yourself. But for this simple game, and just for learning purposes, we're going to keep things simple, and we're going to just remove the enemy from the list when it goes off the left of the screen and we can't see it anymore. Now, the way I can do that is I want to say, if the position of this enemy, or the X value, is less than -100, because our enemies are about 95 pixels wide, so if I know that its X position is less than -100, it's moved completely off the left of the screen and it can't be seen. If this is the case, then I'd like to remove it from the collection, but I'd like to do that for all of my enemies. And you might be thinking to yourself, well, we could just use the for each loop, right? We can say for each enemy, E in enemies, let's check its X value and see if it's less than -100, and if so, just remove it from the collection. The problem with that is that we can't modify the collection within a for each loop. We can use for each to iterate across the collection and deal with each member in the collection, and we can modify those members, but we can't add and remove anything to that collection in a for each loop, because the for each loop would get confused and get messed up. So instead, what we need to use is a for loop. Now, a for loop is very similar to a for each loop, but structurally it's going to be slightly different. So I've got three parts to my for loop. Inside these parentheses, I have something that's going to happen only once before the for loop ever runs, and in this case, I want to create a new variable called I, and I'm going to set that to enemies count -1. So I want to start off this variable I, this counter variable I, and I want to initialize it all the way to the end of my collection, meaning I is going to be equal to the number of entries in this list -1. So if I had 10 enemies, then I would be initialized to 9. Now, the reason I do this is because within the list, the spot in the list actually starts counting by 0. So if I had 10 enemies, then they would be at positions 0 through 9. So if a count is 10, then I want to start I at 9, or count -1, so that I'm starting at that 9th spot and I'm looking at that last enemy in that collection. I want to be able to specify whether I should keep looping or not. So this for loop needs, in the second piece of this space inside the parentheses, it needs a conditional expression. And it's going to go right here where my cursor is to say, if this condition is true, keep looping. So in this case, so long as I is greater than or equal to 0, I want to keep doing this for loop. So this spot, in the second spot in my for loop here, we're going to use semicolons to separate these out. And this first piece is run the first time before the loop is ever run. And then this next piece, this second piece, is the conditional expression that says, should I keep looping? When I get to the beginning of this for loop, I'm going to look at this conditional expression and say, should I keep going? And if so, then do the work inside the for loop. But if this conditional expression is false, I want to stop looping and drop out of the for loop and continue on with the code after that for loop. So I need a way to stop working, to stop repeating. This last piece is going to happen at the end of the loop, right before I come back up and repeat the loop. And in this case, I want I to go back down. So I is going to go minus, or be decremented. And so this loop is going to start at the end position of my enemies collection, and it's going to continue moving I down by 1 every time I go through this loop until I becomes less than 0, which means I've already processed all of the elements and I want to leave and stop looking. Okay, and then the work here inside this for loop is to actually see the enemies collection at position I and look at that X value and see, is it less than -100? And if so, I'd need to remove this enemy from the collection. So enemies is our collection, right? We have the entire list here, and I can use this square bracket notation to say, I don't want the entire collection, I want a piece of it. So this is treating the list like an array. We haven't really talked about arrays yet, but It's enough to know that I can use this square bracket and specify a number, and I'm going to immediately jump to that element within my list and access that individual enemy. And once I have that individual enemy, I can look at its X position and see where is it on the horizontal axis. And if it's moved all the way off the screen to the left, then I want to actually remove it. So I can take my enemies collection and I can remove at, and I can specify the index or the integer that represents the position of this. Now, can you take a guess as to what that might be? Sure, it's the value I, because I starts off at the end of the enemy's collection and it's decrementing all the way down to that 0th spot. And if the ith enemy X value is less than -100, then I'm going to remove that enemy at the ith position. So the remove at function is going to go into that spot that I specify and remove that enemy out of there. Now, you might be looking at this and thinking, okay, why did I start at the end of the list and work my way back to the beginning? And that's because if I remove an element, I'm actually changing it, and I would be shuffling the spots or the enemies within the collection. So if I started at the beginning of the list, at the 0th spot, and I went left to right, or from the beginning to the end, if I were to remove something, then the logic gets a little bit odd in how do I handle that if they've all been kind of shuffled to the beginning. But by starting at the end and working my way to the beginning, I can easily remove something, and if the things after me get shuffled back, it doesn't matter. I'm still just decrementing and looking earlier and earlier in the list. So it doesn't matter whether I've removed something or if it's still in there. I'm just continually moving earlier into the list, and everything that might be shuffled is going to be things that I've already looked at. Okay, so you really have two options. I can start at the beginning and go from the beginning to the end of the list in this for loop, or I can start at the end and work my way to the beginning. And the logic is, if I'm going to be modifying and deleting elements or inserting and adding elements, it's easier to start at the end and work my way to the beginning. Okay, so this for loop, just to review, I've got 3 pieces to it. The first piece is I'm going to do some initialization and some work before the loop ever runs. The second piece is a conditional expression that says, should I continue to do the loop or not? And this third piece is going to happen at the end of the loop, right before I come back up and do my conditional expression. So in this case, I'm decrementing I. So let's run this and see what we get. Every time I handle my enemies, I'm going to see if I need to add a new enemy. I'm going to update all of the enemies in the collection, and I'm going to look to see if I need to remove any enemies. And so what we should get is, as the enemies move off the left of the screen, we should see that our enemy counter is now going down. So let's run. And here we have 4, 5, and now 6 enemies. And you'll notice that the enemy count is going down because the enemies, as they're moving off the left-hand side of the screen, are being taken out of that collection, and being that memory that they used to occupy is being freed up. Okay, so the enemy count is hovering right around 3 or 4 because that's really about all we ever have on the screen at any given time. Sometimes slightly less at 2 or slightly more at 5, but this shows you that we can manage our collection intelligently, and as the enemies are moving off the left of the screen, we're going to be taking them out of that. Okay, so let's shut this down. So you should have a bit of an understanding of how the looping works here, and I want to demonstrate this explicitly by using what's called a breakpoint. So you'll notice that we have a space over here just to the left of these line numbers, and if I click in that, you'll see a red dot is being added, and then this line is highlighted here. And what I've done is I've inserted a breakpoint, which means when I run my program, as the program gets to this spot, it's going to pause, and it's going to let me examine variables, and it's going to let me trace through and debug and see how the program is running. So go ahead and put a breakpoint there at what I have is line 103 on this for loop. And if we debug our program by hitting F5, you'll notice that the program starts to run, but then it stops here, and you can see this yellow arrow is pointing to this line. It's saying it's about to run this. We can put our mouse over these variables, and you'll see that the values show up. I can pin this if I want to keep track of this variable, which would be kind of nice to do. I can do the same thing with the enemies collection. So now I have this enemies, which not surprisingly has a count of 4 because I added 4 enemies into my collection. and I can expand this and see details of this. Remember, enemies is our list class, so I can open this up and I can look at the items, and in this case I have 4 enemies, and I can open those up and I can actually see their speed and their XY positions. So I can drill down and really get into the guts of what's going on in memory here as I go through. So not surprisingly, I have 4 enemies. I was equal to enemies.count minus 1, and since the count is equal to 4, I has a value of 3. So we've run this now. I exists and has a value of 3, and the next thing I'm going to do is test to see whether I is greater than or equal to 0. Well, since 3 is in fact greater than or equal to 0, it's going to do this work. So what I can do is come here and I can step over or step into. Step over is going to run and go to the next line. So I'll push F10, and you'll see that the active line is now what is highlighted here in yellow. This enemies sub I is going to be enemies, and I is 3. So we're looking at this particular enemy, the last one in the collection, and we're seeing what is its X position. Here, its X position is 1005, and 1005 is not less than negative 100, so I should skip this line. So if I hit F10, you'll notice that it skipped that line. It came back to the beginning of my loop, right? And now I'm going to run this I minus minus, and it's going to decrement I down to 2. You see how it changed there. And now it's going to do my test to see is 2 greater than or equal to 0, and it is, so it's going to drill into this for loop and do the work again. Now that I is equal to 2, it's going to look to see is the X position of the enemies at position 2, in this case it's 1005, is that less than negative 100? And it's not, so it's going to skip this line. It's going to come up here. It's going to decrement my I because it needs to do this work. Remember, this third piece of the for loop happens when I return to the top of my for loop. So I should go down to 1. It's then going to do this conditional test, and is 1 greater than or equal to 0? And that is in fact the case. So it's going to continue this loop. And now it's looking at enemies at position 1. Right, so let's go and see what that X value is. Here it's at 1107. And 1107 is not less than negative 100, so it's going to skip this. It's going to come up here, and it's going to decrement I. I is now 0. 0 is greater than or equal to 0. That's still true, so it's going to go into my for loop here. And now we're looking at the enemies at position 0, right? And its X position is 1056, and 1056 is not less than negative 100. So it's going to come back up here. It's going to decrement I to negative 1. Negative 1 is not greater than or equal to 0, so it's actually going to leave my for loop now and come down below here. There's no more work to do inside of this handle enemies, so if I hit F10 again, it's going to come up here and show me that handle enemies is done, and now I'm continuing on in the rest of my update. So setting a breakpoint like we've done here, and then iterating through and going step by step using that F10, 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 step over, step over, step over, is a really good way of seeing exactly what's going on in your program. And I can look at the values of each of these variables. Notice now I is an unknown identifier because it was only declared here at the beginning of the for loop, so I only exists and can only be seen inside of that loop. Now that I'm not in that loop anymore, then I has no meaning. Okay, so I'm going to turn off that breakpoint by clicking on that red dot and removing it. If you're done debugging, you could just continue and let the program run. And so we're back to our program here. You can see we've got quite a bit of enemies coming in, and if you want to know why that is occurring, it's because so much time has passed while I was debugging. All of that time delta really built up to be a huge amount, and so realize that as you're debugging, you're really kind of modifying the real-time aspect of it, and once that's kind of purged through and cleared through, now we're back to our regular game. So don't think that there's an error there. It's because we spent so much time debugging that a lot of 2-second intervals went by, so I'm going to create a ton of enemies. What's interesting to note, I don't know if you noticed it, but the frame rate really dropped down to about 1 frame per second or so because of that number of enemies that was being drawn there. So you can use your debugging, and it's a useful tool to trace through and really understand what's happening. And hopefully now, after you've done that, you can see how this for loop really works. but it's important to be able to debug and to be able to set breakpoints. If you want to know what's really going on in your code, you can set as many breakpoints as you like, and anytime your program gets to one of those breakpoints, it's going to stop and deal with that. Okay, so just as a review of what we've done here in this session, we updated our HUD to keep track of the number of enemies, so we added that label for the enemies there, and then inside of our main application we updated the enemy count. We invoked this function in the HUD, and also in the handle enemies we started looking to see for each of these enemies we're going to iterate across, starting at the end of the list and going to the beginning of the list. Has the enemy reached so far to the left that we can't see it anymore? And if that's the case, I'd like to actually remove it from the collection. Okay, we also talked about debugging and how to set breakpoints, and hopefully you're a bit stronger in your programming skills now and understand for loops and understand how to remove elements from a list.